So I assumed a 0.35 gear width on the teeth, and then I have a 0.37 clearance between the teeth, and that's to make room for oil during the drive. And so you have engagement on one side, oil on the back side, and then you have a backlash of 350 minus 370, which is 20 thousandths, which I don't know if that's a lot of backlash or not. I don't know anything about gear design, but that's something that a real mechanical engineer would know a lot about. So I think that's good enough for a mock-up. So now I'm just making some lightweight through holes on these, because before I made those cuts, that particular output gear was like 20 pounds all by itself, because it was alloy steel, probably heat treated. But the guys at 74 Weld have a really great video where they explain all the different materials that are used, why they use 7075 aluminum, why they use, as opposed to cast iron, which is traditional for high volume automotive manufacturing, why they use heat treated steel on the gears, and their gears are unbelievably strong. So now I'm just making some snubs there to capture the bearings, and checking all my clearances on everything. And we're getting pretty close to the end of the design. So the last thing that I need to do is make sure that I have all my chamfers in the right place, make sure I don't have any interferences anywhere, and look at every aspect of the design to make sure that it's the way that it's supposed to be. And so this final cut here, this is what I started with when I was saying that I just increased one of my constraints. So rather than making this thing 2 inches smaller than it needs to be, I just need to make a 2-inch cut on the top of that part that hits the wheel. So that made the design a lot easier rather than starting from scratch again. And it ended up working out really well. I just need to make some machinable features here. Again, I'm assuming that a part this big and complicated is going to be done on a 5-axis mill, and so with a lot of ball end mill operations. So what I'm doing is, for all the big cuts, I'm using either a 1/2 inch radius or a 1/4 inch radius to assume a 1 inch ball end mill or a 1/2 inch ball end mill that can get in on all those weird operations. So there we go. That's the design.